They will, if you come with a working or not working chip and say, I would like to have some modifications, but I cannot or I don't want to change the production line, or if I put it in the production line, make this a new process, it will probably take months or years, and it costs lots of money. So you can go and by hand start editing features on an existing circuit. And since you have all the tools, you can cut through wires, you can drill holes in the surface, you can deposit insulators, you can deposit metals. The only thing you cannot do is make a new transistor, but everything that has to do with wiring, you can do. So what is cast into silicon is no longer unchangeable. So what does it mean in a nutshell? We have this awesome device. We can do lots of interesting things with it. We can create and modify structures on a nanometer scale. We have, if we use it together with the analytical capabilities that are out there, electron diffraction and other things, we can really look at features of interest in a way that was never possible before. There are some limitations. So since you have a very precise instrument, you also have a very small area you're working on. So if the chip is a square millimeter, but you're actually working on a 10 or 100 nanometer scale, you cannot definitely change a whole chip. That would just simply take too long. The other point is that these devices are still fairly expensive, so you need some deep pockets if you want one. Now, the reason why I actually gave this talk. So we are about to buy one of these devices. So we have this really nice tool, and I thought maybe we can do something useful with it. So having this possibility to change, modify circuitry, I thought might actually mean that we can do some things that people did not intend. But this is a problem. I know too little about it. I had the feeling that, for example, where you have hardware that allows you to write in it once, like you would have in an RFID chip, maybe the one in the passport, you can actually change that afterwards and make it rewritable. So if someone has an idea how to do this, or has an interesting idea how to use this tool, I think a lot of people would be very happy to try it out. And thank you for listening.
Does anybody have any questions?
Hi there. Yeah, I was just wondering, because you just said a lot of people would be very interested in trying out any of these ideas. I'm just remembering a few years ago when Bunny gave a talk about hacking the Xbox, when he mentioned to, I think, his university or wherever he was working, that he was using their equipment for analyzing the protocols inside the Xbox, they went completely crazy and said, you can't do this, you're going to get us all in a lot of legal trouble. So I'm wondering, how interested would they really be? Because I think most of the stuff we would come up with would get you in a lot of trouble.
My take on that is, first of all, there's different people making decisions and working with the instruments. So this is a completely different level of hierarchy. So put it like that, I've never seen any of the people making the decision actually in the clean room. So, and I mean, actually, they should be interested in it, because if you can do things, other people might find out. And these instruments, they are few, but they are not like unreachable. You have lots of students, maybe we are fighting terrorism if we do it.
Any other questions?
I think it would be interesting to do to use these systems to do smart card reverse engineering, because a lot of smart cards, for example, in Germany it's popular Geldkarte, that use cryptography, and the whole security relies on storing the secret key into the smart card and do not get it out. So it would be interesting to just maybe fiddling out to change the whole chip with soft and hardware to make it expose the secret key that is stored into it. And I'm quite sure they make take some defense tries. My English is very limited, sorry, to just avoid this. But I'm not quite sure how good it works, and I think it would be very interesting to just try it out.
Yeah, that was also my feeling. And I think there are actually no countermeasures. Because first of all, it's a new path of a new attack way. So I think no one has thought about that. And second, there is just no way. What would you do? There's nothing that can stop the ion beam. So I can cut through anything. I mean, it's not as simple as that. Of course, you have to know what you're doing. Basically, you need to know how the chip looks. But of course, if you have two and you can destroy one, there are ways to find out.
Yeah, the Geldkarte is maybe not a good target because they use per card individual keys. They have the key is diversified, so each Geldkarte has a different key, so you can't do a lot of nice things with these. But there are a lot of other different systems. For example, the MyFair cards, which we use in our university's cafeteria to pay for the meals, and a lot of people use them for building access control. Their whole security relies on these cards that they use a cryptographic algorithm which nobody knows. It's security by obscurity. They have probably weak cipher with 48 bits, and their whole security lies on that nobody knows the cipher. So maybe you could just open the chip, reverse engineer the cipher, or on these cards actually there's a key stored, you could read out the key if you can make it.
I mean, opening is probably not the problem. Of course, you have some sort of current coming through this whole thing. So I don't know whether you destroy the data, but hey, we can find out. Huh?
Well, to the countermeasures, I think I'm quite sure that they try to detect air into the chip, and if air is detected, the whole key is destroyed. So you have to do this in vacuum.
Actually, as I mentioned, this whole thing anyway has to work in vacuum. So. Sorry? This is anyway a vacuum system.
Okay. So they detect. They try to detect ion beams because the common attack is to use ion beams to flip bits into registers, and therefore create program failures. And so they try to detect ion beams and just kill the public key, the private key. They try to detect temperature variations that are unnatural and kill the... I think it's quite well secured, but it would be very interesting to find out how well they did that.
With regard to the lack of countermeasures against this type of attack, I know that at least one type of microcontroller conceals its bits for whether or not you can read code out of the chip under aluminum shields. The idea being to prevent those bits being influenced by ultraviolet light if somebody were to depot the chip. Would putting key components of the chip above other ones defeat the ability to analyze the underlying ones using this type of technology?
I'm not sure whether I got the question completely because we have some serious interference going on here, acoustic interference. So you say there's an aluminum cover over the chip.
Over individual fuses on the chip.
I don't necessarily see how that would be a problem.
If the aluminum cover were replaced by, say, other parts of the chip using a three-dimensional construction process, would you... Essentially, I'm saying, is it possible to construct a chip such that analyzing part of it destroys another part?
Yeah, that's probably the case. So this focused ion beam is an inherently destructive method. So whenever you look at something, you change it. That's, to some extent, you can go around that by using in these dual beam systems, using the electron beam to image. But still, if something is underneath the surface, you have to cut it open. But you might be able to repair it afterwards.
Are there no other questions? Okay then.